When did you get those socks? Boy? Sorry.
I think you're confused.
Sorry. When did you get those socks? I don't know where I got my socks. I've never seen you. You don't see my socks. They're in school. No, you don't. How? Because I check. Shit, I check you too, because you like to not pull out the socks sometimes. What about I was like, how about you? I didn't know this would be. Did you get that bag in your mom? I did. I grabbed it and I put it in the recycling bin. Okay. Because it was stupid.
All right, ladies and gentlemen. We're going to take our quiz in just a few moments. Lily and Evelyn, you two normally work together in the lab, correct? Okay. All right. Jordan, you normally work with Jose? Okay. And Audrey, you normally work with Michelle, right? Okay. So after the quiz today, Jordan and Jose, you can get together in the lab. You can help give him the results from yesterday. Same thing, Michelle, with Audrey. Okay? Lily, you and Evelyn will have to go back and you'll have to do a few calculations. Okay? So in the back, there is a sheet, a blue sheet on that station in the middle over there that you will go, and there are 6 questions. Okay? You're going to need to answer them because that is what they worked on yesterday as a pre-lab. Okay. So for those of you who were here yesterday and those of you who were not, we're going to go over a little bit of the lab first, only so that when you are done with your quiz, you can make sure you are completing what you need to in the lab before we do it next week, Monday. Okay? So when you two are done, you can go back and you can work on answering these 6 questions for calculations for the lab. Okay? So, also, Jordan, Lily, Evelyn, Audrey, you are going to have to copy down some information that I will put up on the board. It's a data table for the lab. Anybody who did not finish copying it down yesterday, you should do this as well. Okay? So yesterday, ladies and gentlemen, we went through and you filled in this portion of the data table for me. There you go. Right here. So this is what you filled out yesterday. This is the part that you guys will have to fill out. So I will leave this up there for after the quiz. You can copy all of this information down. Okay? All right. So where this information gets used and where those 6 questions that you did yesterday go into is they go into your lab here. Okay? Now, this is the lab that we are going to be doing. We're going to be taking 2 aqueous solutions. That means 2 solutions that are dissolved in water. We are going to be putting them into a beaker together, and we are going to be getting a chemical reaction. We are going to create aqueous sodium nitrate, and we are going to create a precipitate of lead iodide. This will be a bright yellow precipitate. Then, ladies and gentlemen, we need to get rid of this stuff so that we only have this stuff left. We'll show you how to do that on Monday. Okay? But the one thing that you can have done, ladies and gentlemen, is you can have all of these calculations done ahead of time except for number 4. So I told you yesterday, this is the calculation that every single group has to do because every single group is using 10 milliliters of lead nitrate. So again, for those of you who weren't here, taking 10 milliliters, converting it into liters, taking it times the molarity, all I need you to do is type in the answer here. Okay? For this one, you needed to change your volume to whatever your volume was on the sheet you were doing yesterday. So Jordan, Jose can help you with that. Michelle will help you with that. You two have it on the top of your blue sheet. Okay? It tells you what volume you're using. Convert that volume into liters. Go into this formula, take out where it says your volume and plug in your volume. Then do the math and get me an answer. Those are questions 1 and 2 on the blue sheet for you. Okay? 1 and 2 on the blue sheet. After that, ladies and gentlemen, we asked you to calculate how many moles of product would be created. Now, please remember, there is a difference between moles of reactant and moles of product. And that is why we use the ratio step in an equation to get out of moles of reactant and into moles of whatever product we are looking for. So you're going to take the volume times the molarity times the ratio. Yes, I know you already did this here. We're doing it again, but now we're adding the ratio step. Now the product, the top of this should be 1 mole of PbI2. If you click in there to take out moles of product and you type in 1 mole and it doesn't let you put the subscript in, just put PbI with a big 2. I don't care. Okay? I don't care, but you need to put 1 mole of PbI2. On the bottom here, ladies and gentlemen, go the moles of PbNO3 from your reaction. Now this one, you can go in here, you can copy this, and you can paste this, so you should have no problem formatting that. Literally highlight this. You can go all the way back to the mole if you want. You can go all the way back to the start here and put it in here, and then all you need to do is change the number out in front from 0.500 moles to whatever number is in front in the balanced equation at the top of the lab or on the top of your page. Okay? So here, ladies and gentlemen, again, you've got to put in that same top here. Whatever you put here, that goes here. Down on the bottom here, go the moles of NaI, again, from the balanced equation. Is it 1? Is it 2? Is it 3? Is it 4? However many, type in an answer. Okay? For those who weren't here yesterday, though, not only do you need to type in your answer, which you do here, and then you select the smallest one, because this is a limiting reagent problem. Which of these two answers is smaller? That goes down here or here, whatever your volume is. Okay? You also need to do the other 5. But the other 5 are already right here for you. This is what goes into the other 5. Here's the volume of sodium iodide, like in that table. So when you're doing 5 milliliters of sodium iodide, that's the number of moles that you will put in there. The rest of you should have this done. If you don't, you should get it done after your quiz today. Okay? Question number, or the next calculation, is to take those moles of lead iodide that you just listed or got from the last calculation and convert it into formula mass. What's the formula mass of lead iodide? Come on, you all did it yesterday. What's the formula mass of lead iodide? What was the number? 461 grams. 461 grams. So this better say 461 grams. Now I'm telling you right now, I go through this every year. I've been through this with you in other labs. And yet you turn in labs where calculations are not done. And you turn in labs where you write just a number with no unit. If you do that, you're going to get downgraded. So include units. Do the calculations. If you don't know how to get in here and change this, you raise your hand after your quiz, you call me over, and I will show you how to change it. But it's not hard. You click in there and you move around and you will be able to do it. That's the reason I format it for you. Get your answer here. That answer then comes down under whatever volume you had. But you need to put in the other answers. They are here in the blue column. So this is the number of grams we should be creating on Monday. Probably not going to be the grams we get, but it's the grams that we should get. You cannot do calculation 4 until after we collect our data on Tuesday. Okay? So on Monday, we're going to do the lab, but we won't have the dry sample until Tuesday. So you cannot do calculation number 4, which is to find what is called a percent yield, until Tuesday. Questions? Okay. So that is what everybody needs to have done by the end of the day today. Any questions before we take our quiz? Okay, on your desk, periodic table, one solubility chart, a calculator, and something to write with, ladies and gentlemen. Okay. Okay. Kaden. Okay. Did you hand the other ones back to me? Okay. Please listen. Problem number 1 says magnesium metal reacts with hydrochloric acid to produce hydrogen gas and magnesium chloride. That is everything you need to write a balanced chemical equation. You need to include the states of matter for each of those 4 things. Why? Because you should be able to, know what state of matter a compound is in a single replacement reaction. So, balance the formula, states of matter, and each compound correct. Then, ladies and gentlemen, you begin with so many grams of magnesium. And it asks you to find the volume of hydrogen gas given 2 conditions, some amount of kPa's and some degrees Celsius. So, you are beginning in grams, you are going to volume given a pressure and temperature. Finish that problem. On the back side is the second problem, ladies and gentlemen. You do not have to write a balanced chemical equation for it because it is already there. So it tells you what volume and what molarity of aluminum nitrate reacts with excess nickel. You then need to figure out what mass of nickel nitrate would be created in this single replacement reaction. So you do not have to write the balanced equation. You just have to figure out from what you're given how to get into the grams of product. If you have questions on the quiz, ladies and gentlemen, raise your hand, call me over. You have 35 minutes to get it done. But I'm going to put up the table for the lab up there, so I will let you know when there are about 10 minutes left or 5 minutes left. Go to work, ladies and gentlemen. If you have any questions, please raise your hand and call me over. two formulas is wrong. Yes, it is. One of those two formulas is incorrect. One of them is not correct. Now, if you're sure of one, it's probably the other. But one of them is not correct.
Because it has.
You have to know this. You're missing the start of the acid myth. Yes. If that's the way you write hydrogen, then it's a bonus. I'm not arguing you about the end of your name. I'm arguing with you about the beginning of it, which tells you something about that acid. Three steps to convert what you're given into moles. Use the molar ratio, report out in the final unit. Final unit is what you're trying to find in the That's it. No, sometimes you don't have to. Sometimes you do. But again, take what you were given, what you started the problem with, pretty much it's on the left-hand side. Get it into us. About 10 minutes left, ladies and gentlemen.
Use a
Just under 5 minutes left. Last minute and a half, ladies and gentlemen. All right, ladies and gentlemen, please bring them up. Take out your computers, open them up to your EISN, get to slide number 28, please. Thank you very much. Thank you. Thank you. All right. Today, ladies and gentlemen, we're going to talk about one of the final things on this unit. And that is what happens to ionic compounds in water. Specifically, we're going to talk about what happens to their molarity. Okay? So, ionic compounds in water are compounds that break apart because they are aqueous. When they break apart because they are aqueous, ladies and gentlemen, that causes the amount of ions in your solution to change. What doesn't change is the amount of solution that is there. Okay? So, excuse me. One of the things you need to understand is molarity, that capital M means a whole bunch of things. It literally means the moles over liters. That is what molarity actually is. So you could say molarity. What you're really meaning is the number of moles over liters of solution. Another way of saying this, ladies and gentlemen, is to call it the concentration. How strong or how weak a solution is. Okay? We put brackets around a substance so that we can say that is the concentration of that substance. So this is a shortcut way of writing concentration, is to put brackets around it. Okay? Now, for molarity or concentration, number one, the substance has to be dissolved in water. Now, you can dissolve substances in other things, but for everything that we are going to do in this class, we are going to talk about them being dissolved in water. In water, they become aqueous. If they become aqueous, they make a solution. If they make a solution, it may or may not be saturated. Okay? So if they talk about a saturated solution, it just means it's a solution holding ions in it. Okay? So that is the basis of what we were going to talk about. Now, if you have a compound and it is aqueous, when you put it into water and it breaks apart, that is called dissociation. I'm giving you vocabulary here, but again, I'm not going to quiz you on your test on what is dissociation. I'm not going to ask you to define concentration. I'm not even going to ask you to find molarity. I'm going to ask you to do what you just did. Use those things, okay? Dissociation only happens with ionic compounds. All acids dissociate. That means acid breaks apart into the ions that make them up. Anything that is aqueous according to our solubility chart will break apart into the ions that make it up. That means they will all undergo dissociation. Okay? The basis of this process is to assume 1 liter of solution. To assume that you have 1 liter because it's just easier that way. If the solution was in a half a liter, okay, when the ions break apart, they're still going to be in a half a liter of solution. So the important thing is that when ions break apart, however much solution they are in, that stays. So it doesn't matter how much solution they are in, we can assume it is 1 mole for what we are going to do over the rest of the period. Now, what we do need to understand is that when we are given the molarity of an aqueous solution, what that aqueous solution will really do is break apart into the ions that make it up. That is what happens. Okay? Now, if you look at this, just the way it is written right now, is that a balanced chemical equation? Absolutely. One sodium over here, one over here. One chlorine over here, one chlorine over here. Okay? So I have a molarity of this substance. Okay? And we are going to assume 1 liter. If I have a volume and a molarity, I can get to what? Moles. How do I do that, Alan? We multiply them together. So if I take 1 liter of sodium chloride times the molarity of sodium chloride, written out as moles per liter, I will get into moles, correct? This ratio comes from right here. For every one of these, how many of these are there? 1. So 1-to-1 ratio. That means that in 1 liter of 2.25 molar NaCl, I should have 2.25 moles of sodium ions. Okay? Now, if I know the moles and I know the liters, I can now find the what? Moles divided by liters gives you what? Molarity. So if I take the moles divided by 1 liter, I can find the molarity of these ions. What do you notice about the molarity of these ions? It's the same as the molarity of the solution. Why? Because it was a 1-to-1 ratio. So tell me, what do you predict the molarity of the chlorine ions to be? Will be the same. 1 liter, how much solution we were given, times the molarity. 1 chlorine ion for every 1 sodium chloride gives us 2.25 moles of chlorine. And again, it's still in 1 liter of solution, giving us 2.25 molar solution. The molarity did not change. Why? Because everything in this compound is in a 1-to-1 ratio. Questions? So when do you think these molarities will change? Well, right now they're all the same because what's the ratios? When the ratios change, the molarity will change. Now, can you have more than one of something in something else? Well, let me give you an example. A Big Mac is 2 all beef patties, special sauce, lettuce, cheese, pickles, onions on a sesame seed bun. Why are you laughing?
That was a song.
What?
Wasn't there a song?
That was a song. Not only was that a song, but when I was a kid, McDonald's ran a special where if you would walk into their store and sing that jingle, you got a free Big Mac. I was never afraid to walk in and go 2 all beef patties, special sauce, lettuce, cheese, pickles, onions on a sesame seed bun. The worst day of my life is when I found out that advertising ended. And you no longer got a free Big Mac when you walked in and said that. But that's what's in a Big Mac, right? 1 sandwich, correct? How many burgers are in that 1 sandwich? 2. There are 2 of those things in that 1 sandwich. How many buns are in that 1 sandwich, or how many pieces of bun are in that 1 sandwich? 3.
Oh, there's another one.
There's 1 in the middle. Top, bottom, 1 in the middle. So, 1 sandwich is made up of 2 burgers and 3 buns, right? That is a ratio to that 1 thing. Okay, you don't like food? Let's talk about a car. How many steering wheels in a car? 1. How many tires? 4 tires. go into making one car. 4 parts into making this one thing. In that sodium chloride, there is 1 sodium and 1 chlorine in it. That's a 1-to-1 ratio, right? What happens if it's not a 1-to-1 ratio? What happens if it is something like this? What happens if it is MgNO3 in parentheses 2? Now, that breaks down into how many magnesiums? 1. But now how many nitrates? 2. So now you got your Big Mac with 2 burgers in it.
Wait, I have a question.
Okay, go ahead.
Is it still the same if it's like 2 to 2?
2 to 2 would still be a 1-to-1 ratio. Absolutely. Correct. Yes. But here's the thing. This is the compound, right? Okay. You would never have 2 to 2 here. Why? Because you would reduce it. And the only way to have more of these compounds is to put a number out in front. And if that number is out in front, then yes, it will turn out to be in front here too and here as well. So yes, you could have 2 to 2 of these. But then how many of these would there be?
2.
No.
6. 1.
Stop. You're guessing. If there is 2 of these for every 1 of these, if there were 2 of these, how many of these?
4.
There you go. Same ratio. We've just increased it to a larger number each. Instead of 1-to-1, 2 to 2. Instead of 1 to 2, 2 to 4. Okay? Same ratio though. Okay? So now let's again assume 1 liter. And let's again give you the molarity of this. Okay? So now if we're going to figure out magnesium, we again take 1 liter times the molarity times our 1-to-1 ratio. What is going to be the molarity of the magnesium here in the 1-to-1 ratio? What? It's going to end up being 0.565. Because again, we end up with 0.565 moles divided by 1 liter gives us this molarity. The amount of solution it was in didn't change. Okay? But now for the nitrate, what do you notice about the amount of ions that you create? It is what compared to the original compound? 2-to-1 ratio. What's going to happen to your molarity? How?
Doubles.
Thank you. It doubles. Because now, in this step right here, instead of 1-to-1, there are 2 of these to every 1 of these. So that means this number doubles. Well, when you put it over 1 mole, guess what happens? You get double the molarity. So your molarity of nitrate ions in solution is 1.3 or double the 0.565 molar. Why double? Because there are 2 of these for every 1 of these. Ratios always hold. Questions? Okay, so again, from magnesium nitrate to magnesium ions, 1-to-1 ratio, that's why the numbers stay the same. From magnesium nitrate to nitrate ions, it's a 1-to-2 ratio, that's why the number doubles. Okay, questions? So now, how do the aluminum ions compare to aluminum sulfate here? How do these right here compare to this right here?
There's 2 aluminums by itself.
What?
There's 2 aluminums by itself.
So what's the ratio? How many aluminums to how many aluminum sulfate? 1. 1 what? How many aluminum ions compared to aluminum sulfate? What's the ratio? I'm talking about this and comparing them. How many of these?
2.
How many of these? 1. How many of these things?
2.
2. How many of these things? How many of these?
3.
3. What is going to happen to your molarity here? It's going to double. So instead of 1.16, 2.32. Because of the 2-to-1 ratio, the moles double, which means the molarity doubles. What happens here? It triples. It becomes 3.48. Again, the 3-to-1 ratio triples the amount of moles of it, which triples its molarity. So if you are given a compound and it breaks apart into ions, whatever the ratio of compound to ions is what happens to your molarity. If it is 1-to-1, the molarities will be the same. If it is 1-to-2, your molarity will double. If it is 1-to-3, your molarity will triple. Questions, ladies and gentlemen? Okay. On Monday, ladies and gentlemen, we are going to do our lab. Okay? Now, what's going to happen is on Monday, when we do the lab, different groups are going to be together. What I mean by that is, who had the 30 milliliter yesterday? Chia, who are you with? Okay, so you guys are going to be at one of the groups with who had 5 milliliters yesterday. One of you will be with that 30, the other one will be with the other 30 group. So when you come into the lab on Monday, ladies and gentlemen, this side of the lab and this side of the lab will look the same. I will have these cards out for you. Whatever color you worked with on your sheets yesterday or today for you guys, that is the color station that you will go to on Monday. Because what I've done is I put the group that has to do 5 milliliters with the group that has to do 30 milliliters, so that at that station you'll use 35 milliliters of the sodium iodide. So then I'm going to put the 10 milliliter with the 25 and the 15 and the 20 together. That way no one will run out of solutions at their stations. Okay? Now, you are going to take and you are going to filter your solution through filter paper. The reason for that is your precipitate is a solid. A solid is a bigger piece of matter. This filter paper will catch solid lead iodide, but it will let ions in solution go right through it. And those ions will then end up in the bottom here where we don't care about them. And this filter paper we will put with the precipitate that will be left in the bottom of this container, and we will keep them together. Now, the hard part of this lab is that we need to get rid of the ions that are still in solution in here that are in the same place with the precipitate. So what we are going to do is when your precipitate settles to the bottom, we're going to take the water and we're going to pour it off through this filter paper. The filter paper will catch any solid that may still be floating, any little bits of solid that are still floating at the top. But the ions will go right straight through. Then what we're going to do is we're going to add some more water and do it again. Why? Maybe some of those ions are trapped in the water with the precipitate. you want to get rid of as many of the ions that are in solution and keep as much of the precipitate as you can. Now, our 5 milliliter group, there's not going to be a lot of stuff in here. You'll be able to rinse this down 4, maybe 5 times. But the group that has 30, you're going to have a lot of liquid in there to begin with. You may only need to rinse it down once or twice. We will show you how to do that on Monday. We will also, ladies and gentlemen, show you how to measure using these things. Okay? So this is a pipette that will measure the volume of liquid that you put up in here. So you're going to put this into a container and you are going to pull up however many milliliters of liquid you need, up to 10 in here. And then you can take and transfer it over to another container and release the liquid and it will drain out for you. Okay? Now, yes, if you have 20, you're going to need to do this twice. If you have 30, you're going to need to do this 3 times. Okay? We will show you how to work that on Monday. Questions, ladies and gentlemen? Okay. Can I get those blue sheets back from you, please, Lily? Thank you very much.
I was trying to put stuff in and it like broke my computer. Not really, but it just keeps reloading a lot.
Yeah, I had that
I
problem
don't-
yesterday, too.
What should I do?
I would
Like,
say sign out, shut it off. Because I had that
'Cause I
problem
just, like,
yesterday while I
pasted-
was...
I pasted like one of the things and it just
I
like,
did the same thing. And I think what happened is when you're in a formula, there's a box around it.
yeah.
And if you try to paste something from in the box, outside of the box, that's when it gives you that error.
And then my computer doesn't like subscript and
Well, here's the thing. If you can't do a subscript, Lily,
yeah.
just do PBI with a capital 2 and I'll accept that. Okay?
My computer hasn't done something. It doesn't like anything. It doesn't like two shortcuts.
But I had that same problem yesterday. Literally during 5th period, I could not show them things on my lab because it just kept shutting down on me. Have a good weekend, ladies and gentlemen.
No, I didn't do that. Oh, I didn't realize I'm probably somewhere.
Bye, ladies and gentlemen. Have a good day. Thank you.